Hey, this is lessons 54 through 58 of Saxon Algebra 1. Lesson number 54 is solving simultaneous equations by substitution. I'm going to give you an example of what it is we're talking about. These are linear equations. What that means is if you were to graph them on a XY coordinate plane, and you were to make a little chart of, if X is something and Y is something, we filled that in, we would have a bunch of dots. And that would be a line. And then if you had another equation, X equals 3Y minus 10, for example, and did the same thing, you would have a bunch of new dots. Okay, and when we say solve this, what we're looking for is where do those two lines cross? It crosses at a very specific X and Y spot. Okay, so we are looking at where do these two lines cross? Well, one of the methods is to draw the picture. We're not going to do that because picturing is, as you can tell just from my quick sketch, it'd be pretty hard to get an exact answer. We're going to use a term called solving by substitution. What you do is you look at the two equations you have. There's one equation, there's the second equation, and you say, okay, I want to get one of the equations that says X equals or Y equals. Well, in this case, you've already got an equation that says X equals. So what I'm going to do is I'm going to substitute for X, this equation. Instead of using X, I'm going to use what X is equal to and put it in the space for X. So it becomes 3 times X in this equation, only X is now 3Y minus 10, plus 2Y equals 3. So I'm essentially just using this equation, but I'm substituting X, being this, into that space. And this goes now solving this. Remember, I said that the most common thing you use in algebra is the distributive property. This is partly y. So I have 3 times 3y, which is 9y, 3 times negative 10, which is negative 30, plus 2y equals 3. I'm going to put all the numbers on the right, so I'm going to add 30 to both sides. And I get 33 on the right. And 9y and 2y is 11y. And then I'm going to divide both sides by whatever number's in front of the y, in this case 11. So y is equal to 3. Okay, now that I know what y is equal to, I can use my equation that I started with, x equals something, to figure out what x is equal to. So x is equal to 3 times y. Well, y is 3 minus 10. So 9 minus 10, or negative 1. So the answer is going to be x and y is going to be negative 1, 3. That's the point where they cross. Negative 1 over 3. My picture obviously wasn't to scale or accurate. But that's what you're doing, is you're just looking at one of the equations and substituting into the other equation. Okay, I'm going to give you a slight variation on that, and so you're not confused. And that would be this one. Let's try one where you have two equations, but you have a choice. In other words, let's look at this one. So how about negative x minus 2y equals 4, y equals negative 3x plus 8. Well, in this case, again, I could use either equation. I'm going to use this one because y is already there. Negative x minus 2 times y, which is negative 3x plus 8, equals 4. Again, I'm substituting y, that's y, using this instead of y, and just rewriting the equation. And again, this goes where the skill of using the distributive property comes in. So I have negative x, negative 2 times negative 3x is positive 6x. Negative 2 times positive 8 is negative 16, equals 4. Put all the numbers on the right. In other words, add 16 to both sides, and I get 20 on the right. Add those two together, I get 5x. Divide both sides by 5. and I get x equals 4. Now I'm going to use this number here, y, to figure out what y is. Y is equal to negative 3 times 4, because that's what x is, plus 8, or negative 12 plus 8, or negative 4. So y is equal to negative 4, x is equal to 4. You could leave the answer like that, or you could show the answer as 4, negative 4. Either this one plus this one, or just that one. Both of those are going to be reasonable ways to show what the answer is. That's lesson number 54. Let's go on to lesson 55 and see what's going on there. All right. Lesson 55. Okay, lesson 55 is complex fractions. And complex fractions are simply this. What if you have a fraction like 2/5 and over 3/4? What do you do? Well, remember what a fraction is. If I have something over something else, like a over b, that means that's the same as a divided by b. It's the top divided by the bottom. Well, if I look at this, that's 2/5 divided by 3/4. But you remember that we generally don't like to divide fractions. What we do is we multiply times the reciprocal of that fraction, or I end up with 8/15. So 2 times 4 is 8, 5 times 3 is 15. Answer. Okay, so this is complex fractions. It's taking the top one divided by the bottom one, and I usually write it out, but then one more step is I take the second one, because it's divided by, and I flip it, and then I just multiply top times top, bottom times bottom. Here's one that might be a little confusing to you. What if you have something like a over x over b over a plus x? Okay, so first of all, this one up here was real obvious because I wrote these kind of 2/5 as a slant, 3/4 as a slant, and it was real obvious. You had the top and you had the bottom. When you have a line, a line, a line, and a line, normally the middle one is bigger. And so this becomes a over x divided by b over a plus x, which is the same as a over x times a plus x over b. Now, if you've got a case where you're just saying this times this, put it in parentheses so you can keep track. A times a is a squared, a times x is a x. And on the bottom, x times b, bx. That's the answer. Okay? That's all there is to. So, that's lesson 55. One more little note on this one that might confuse you, and that is sometimes there's not a fraction shown. So it may show something like this, w over 1 over a plus b. You say, well, now what do you do? Well, it's this divided by that. Remember, that's the bigger line. Write it as w over 1 divided by 1 over a plus b, which is w over 1 times a plus b over 1, which is w times a plus b over 1, or just w times a plus b. That's a correct answer, or you could use the distributive property, wa plus wb. Either one of those is the correct answer. Okay, so that's lesson 55. Let's move on. Lesson 56. Lesson 56. Lesson 56. This one is understanding sets and set notation. In math, we use symbols to mean stuff. Equals, that's a term, okay? Does not equal, Okay, there are lots of things we use to represent words in math. Well, this one looks kind of like an E. It means is a member of. So, for example, in my family, we have dad, mom, girl 1, girl 2, girl 3, and boy. So we would say this is the set of my family. Okay, I would say dad is a member of, so family. Dad is a member of family. Okay, now cousin 1, cousin 2 are not a member of my immediate family, so we could say cousin 1 is not a member of family. And what I mean by that is immediate family. And so these terms, is a member of or is not a member of, that's all it means. So the problems you have on this lesson have to do with, they will give you a set. So they'll say, for example, you have a set, you've got 3, 1, 0, 5, 0, 9, and 5. So this might be any scientific experiment where you get a bunch of data, and this is your data. Okay, and we're going to call this one set A. Okay, so we would say set A is, and we use these braces, that's what those are. It includes, and generally we go from smallest to biggest. It includes a 0, a 1, a 3, a 5, and a 9. Set A includes all of that data. Even though there's more than 1 0, and even though you have a duplicate there, you only count each one time. And so you would say, for example, 3 is a member of set A, or 7 is not a member of set A. Okay, that's how that works. Okay, so a little bit more on lesson 56. That's the easy set part. It's just a matter of understanding the words. The other one is going back to graphing. If you have a linear equation, for example, you might have 2x minus 3y equals 6, and you want to graph that on an xy chart. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now when I do these things and I graph them, and I'm drawing my graphs, notice I don't write 1, 2, 3, 4. I don't put all that stuff. I usually can figure it out if I just representatively put in, like 5. So I can tell where 3 is just by counting. Okay, if I want to graph this, a way to do it is you say, okay, I'm going to make an XY chart. And you have to pick what makes sense. I always pick either zeros or ones to start with. So for example, if x is 0, this equation becomes 2 times 0. Or this becomes negative 3y equals 6. And divide both sides by negative 3. And I get y equals negative 2. So if x was 0 in this equation, I now have y would be negative 2. What if y was 0? I don't know, it would be 2x equals 6, or x equals 3. So there's my 2 points. So I go 1, 2, 3 over, 0 up, make a dot. I go 0 over, 2 down, make a dot. That's my line. So what you're asked to do here is they'll give you an equation, make a draw, use zeros and ones so they get nice clean points, and not fractions, and then connect your 2 points. Again, zeros and ones tend to be the ones that work. Occasionally you have to pick another one, and you'll get better at it as time goes on. That's lesson 56. Okay, lesson 57. Okay, lesson 57 is Basically, dealing with negative exponents. We've done this a little bit in class, but this is the first time your book has insisted on it. So, for example, they're saying, here's an example. This is actually practice problem A, and it's like ax to the minus 1 minus by to the minus 2. And the question is, make this with only positive exponents. Well, you have to remember that x to the minus 1 is just 1 over x to the 1. So in other words, if you see a negative exponent, that means put it on the other side of the fraction. Drop it down. If you had 1 over a to the negative 3, that would be, well, let's say 7 over negative 3, then you would take this and it would become 7a to the third. So if you have a negative exponent, put it on the other side of the fraction. If it's on the top, put it on the bottom. If it's on the bottom, put it on the top, and then it becomes positive. So this becomes a over x minus b over y squared. We've done a lot of those in class. That's really all it is. Give you another practice problem. Let's say you have something like, I won't even use the one from the book. I'll pick one. So here's a negative 2xy to the negative 1 plus a z to the negative 1. Okay, so I just start going from left to right, and this becomes, and I write a fraction. This is a becomes a squared. X is already positive. Y goes to the bottom, plus a is already on the top. Z goes to the bottom. That's the answer. So you've taken negative exponents, turning them to positive exponents. It's a skill we've worked on already in class, but it is something your book introduces as a new thing here in Lesson 57. And that's all there is to Lesson 57 as far as new stuff goes. Lesson 58. Last lesson for the week. Lesson 58. Is percent word problems. Your book uses these funky bubbly things. I'm going to try and explain this a little bit. If you think of a whole of something, we show it as a circle, all of it. If you have more than it, what your book does, it says, well, it's bigger than a whole. It's a whole plus more stuff. So this is maximum would be like 100%. And this is greater than 100% when you're drawing a picture. If you want a fraction of the whole, so let's say you want half of it, they would show it like this. This is 50%, and this would be 50%, okay, of the whole. So how does that work? Well, all right. So I'm going to give you an example. This is practice problem A. Then they're going to say J and F have 32 bagels left. Okay. They started with 160 bagels. Okay. So what percent of the original is left? Okay, so there's two things we're going to do. One is drawing a picture. The second is just do the problem. Now notice this equation. Blank of blank is blank. Did you notice that? Okay, so I'm going to look at that. What percent? I don't know. I'm going to use x. Of, what's the original? 160 is 32. Well, just divide both sides by 160. And I get x equals 32 over 160. And you have to go, okay, what fraction is that? And you take your calculator out and you say 32 divided by 160 equals, and you get 0.2. Or you can fractionize yourself down and go, okay, this is the same as 16 over 80, which is the same as 8 over 40, which is the same as 4 over 20, which is the same as 2 over 10, which is 0.2. So I go with the calculator method, and you're allowed to use your calculator. Just do it that way. It's a lot easier. So we get, and well, the question is what percent? Well, what percent is, that's 20%. Remember, decimals is just move the decimal 2 to the right, and you get 20%. So that's how we solve this problem. And so what they ask you to do in this assignment is they say, go ahead and do this, and they'll say, now draw a diagram as an aid. Well, I have never found these diagrams very aidful, but some people do. So I'm going to show you how you would do that with a diagram. So you kind of started where before and then after is really what you're looking for. It's what they call before-after diagrams. So before you had 160, and that was 100%. And after you had 32. So you're basically saying 32 out of 160, right? 32 out of 160, 32 out of 160 is what percent? Well, notice this is the same that I did here when I was doing blank of blank is blank. So this is another way to get to this equation, where you're kind of drawing what's going on, and it's helping you visualize it. I've not particularly found that helpful, but some people really do, so I'm not against it at all, if that helps you. So that's your lesson 58. And that's it for the day. Next week, moving on. Have a great weekend. And